everyone. In today's video, we are going to explore a Java program that demonstrates basic operations on a linked list using a custom implementation called playlist. We'll go through adding elements, retrieving a specific element, checking a draw replace of value, calculating the length of the list, and finally clearing the list. We will also analyze the time complexity for each operation, helping you understand the incorporated data in the arrays. Let's dive. Firstly, creating the list. Come example, and list, and then list integer. This one, yeah, and name is list. New list. Sorry. Com black example list. Yeah. And then to begin, we analyze a new linked list that holds integers. The array is integer syntax indicates that the list will store integer values. Initially, the list is empty, meaning that both the heat and tiling reference are set to null. This setup prepares our linked list for performing various operations through the program. And this one adding element to list. Yeah, this one list add value maybe 1 and list add elements 20 and finally list adds elements 30. This one, yeah, system out print line list adder after additions. Writing list, yeah, this one, and running the program, yeah, this one, writing. Next, we added elements to list. We used the add method to insert elements at the end. Since linked list typically and elements at the end without traversing the time complexity for this operation O1. Here we are adding the three integers 10, 20 and 30. The list will now contain these elements in the given order. And then printing the list additions, this one method, system on print writing the list, help us verify that elements have been added correctly. Yeah. And then this one, int element list get entry 1, this one, and system of print line element at index 1 and plus element, yeah, this one. To retrieve an element from the list, we use the getEntry method. Since linked list require traversing nodes to reach a specific index. The time complexity for this operation on this one, yeah, on. Here we are retrieving the elements at index 1. The method will start from the heat and move to the next node, which is the time consuming compared to direct access in array. We print this one. We print retrieved element to ensure correctness. This one. Maybe index is 2. Writing 30. Say 30. Maybe index is 0, 10. This one. These methods using. And then 2 30, and then 1 is 20. Yeah, this one. And then checking if the list contains of value, we can check whether the list contains a specific value using the contains method, since it may need to traverse the entire list to find the value. The time complexity is O(n). In this case, we check if the list contains the value 20. The method will return true if found or false otherwise. Printing the results shows whether the value is in the list. Yeah, boolean contains list contains this one 20, and then system out print line list contains 20, writing methods contains, and then printing the result shows whether the value exists in the list. This one 3 maybe contains 25 maybe in this list. Value is false. First writing, maybe it's true. False, but value is 30. This one methods. Yeah, true. Uh, we are in this case we check if the list contains the value for 30. The method will return true if found or false otherwise. Finding 30 in these methods, setting, and then writing true boolean functions because, and then getting the list length integer length, list get length, so system out read line list length, sorry about that, this one, okay, list length, this one, yeah, writing length, yeah, list length is 3, maybe list at this 40, writing 4, yeah, this one methods, and then to find the number of elements list, so we get length method. If the list keeps track of its length as a file to operation O(n), the method directly returns the length without traversing, making it a thing. We print the result to check the current size of the list, and then clearing the list. Yeah, list clear, and then system out break line lifts list after clearing list, and then system output line list length 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 after clearing methods list gets length methods, yeah, this one, and then testing methods, no clearing, no, this one, yeah, and then finally we clear the entire list using the clear method. Depending on the implements, clearing can be effect O(n) if it just resets the heat pointer or slower one if it involves traversing and deleting each node. After clearing, the list should be empty, and we print the list length to confirm these methods. Time complexity, adding element methods, adding element methods O1, and then trace index on and volume contains on and getting length O1 and then clearing list O O1 but this one O1. Yeah, these methods. In this video we demonstrate fundamentals operations on a linked list including adding, retrieving, checking and clearing elements and checking clearing elements. We also analyze the time complexity of each operation to better understand the efficiency of linked lists. By comparing linked lists with other data structures, we can choose the most appropriate one based on use case. Linked lists are particularly useful or dynamic data manipulation, but can be slower when it comes to random access. Thank you for watching. Don't forget to subscribe for me.